So back, just a little bit of background story for on me. I've been programming since a long time ago, since I was a little kid. But in 2008, I had the privilege of working across the street from Greg Young, and what he was doing on a whiteboard kind of is distilled here after 11 years. So a lot of time with CQRS NES, about 11 years of trying to do this, and a lot of hardship, obviously, in the early years where people were looking at you entirely wrong for DDD or CQRS or anything like that, event sourcing. There was really only push to event-driven architectures in really large enterprises or very few select places that that knew what they were doing, but it definitely was not the default for any of the shops out there. So so I wrote my first event store in 2009 and have been doing message-based architectures purely for any project since then. A lot of the challenges are basically non-technical. They're always people problems, and communicating what you're trying to do with all the wonderful technology is a challenge. If you don't have buy-in from most people in the company, especially leadership positions, and you're going to have a tough battle, as we all probably experienced when trying to do things like domain-driven design and all that. So that's kind of the background of how I finally, I had the privilege of Greg changing my mind about how to write software, which was really good. I was deep into Agile before, ran the Agile Vancouver, well, I didn't run it, but I was on the board of the Agile Vancouver organizing committee, and I brought guys like Eric Evans and Martin Fowler and others to Vancouver, to these conferences here. So I have a strong background in Agile, and then in 2008 switched entirely to domain-driven design, CQRS, and event sourcing as the only way to do things. And I had to really dig deep as to why that made sense for almost everything, where the opposite was recommended by Fowler in his 2011 article about this being a specific kind of solution that you would have only here and there. So kind of the background as to 11 years of really searching for what that is. What is the essence of programming, and why it's better to do it with an event-driven, domain-driven design. And it really is in the phrasing and how you have a perspective on what an information system is. I'll start off with a little bit of history. We did have a very small blip in human history, of digitization for information systems. Information systems existed long before computers. And somehow we as a society were able to put together multinational insurance companies, trading companies, all without computers for thousands of years. And so at least hundreds. So what makes the last 50 years so special? The advent of the transistor, right? It was basically removing this this mistake making component, the human being, out of the equation. So the transistor gave incredible speed and accuracy. And we start to get into looking at Moore's law from a different perspective. Because one thing that didn't catch up in terms of speed and accuracy in the same kind of scope was storage. So Moore's law was incredibly kind to processing and accuracy, but it wasn't as kind to storage. So we were given this new capability, but we were given a very, very tiny little square to play in. And that means our traditional way of keeping ledger for a business, like doctor's offices, visits, you have a ledger, they have a form you kind of fill out, they fill out for you with your checkup, and they don't erase anything, but they just keep adding more and more to your file, right? A lot of businesses act like that. And before digitization, it was people at desks with big filing cabinets, and they would file things. So it would be a ledger of what happened. So with digitalization, we had this ultimatum: you either go fast or you keep everything, but not both. And this led to two important things. A, we threw away most records because we couldn't have them online because of storage. B, we threw away the idea of having multiple models. And because of storage restrictions, we had to have one model. That's kind of like where the monolith came from. It was really Moore's law constraints, and third normal form was the default. So that had a lasting effect, because it wasn't until the last couple of decades when you could really start to think about supporting multiple models as a default way of working, let alone ledger. So what happened is that we've had decades and decades of formative years, basically having the tooling being made so incredibly mature, but for solving a problem that is no longer there, or at least having the tooling skewed to the opinion that you should always be extremely efficient at any cost with your storage concerns. So that's one aspect. The other thing is to look back at why we use ledger and how our minds work, and just why information systems were organized by humans in this way. And one of those things is that as what brought us from animals to human beings was being able to persist memories through generations. And that you could see as being something that was done for cave paintings and I don't know, stories, fables, the Bible, all sorts of religions, folklore, whether spoken or written. There's always parables and stories and things that were memorized. And that's kind of important, because it's how our minds work to remember things, whether it's auditory, visual, or just logical, how we remember stories. We work off of key frames, and we see this in the movie industry, have key frames on a storyboard to mark places in the film and things like this. So we have a lot of evidence that our minds work on reference points. Whether you're talking about an image, we don't see pixels like a camera, we see edges, and our minds fill in the rest of the picture. Same with sound, same with stories. If someone remembers pi to 1,000 places because they learned to memorize it, you'll notice that they don't memorize every digit. They memorize patterns, and there's clues as to what that story of reciting pi is. So our minds have a very specific way of working with timelines and stories and these key frames. So those two don't seem very related, but they are. And as we unwind the constrictions of having basically Moore's law giving us this tiny rectangle to kind of play in, we're now moving out to more freedom and basically allow digitization to play in the same field as traditional information systems were played. So back to the word information system. The reason I say information system and not software is because we're talking about a very specific piece of software. It's very specific, but it's also incredibly broad. It ends up being 99% of the lines of code that are running out there in the world are to serve information systems, whether it's your bank, your insurance company, your online shopping cart, etc. Any SaaS product, most of the SaaS products out there are literally information buckets where they move things from A to B and maybe transform them a little bit and nothing more. I.e., you don't need a computer science degree and keep solving computer science problems just to be productive at a company these days. And that's why you have the boot camps, etc. And people get into programming very quickly. And that's natural, because most programming tasks are not making the next cryptographic algorithm or whatever, or a better binary tree or something. It's about moving information from left to right. So having that knowledge, we can swipe to the side quite a lot of jargon when we're discussing things. And so event modeling came up of the last 11 years of thinking in that area where we don't have to concern ourselves as a primary purpose of Moore's law. We can have compensating actions if we start to run out of disk. And those are not going to be crippling things like they were in the 50s and 60s. Back then, an IBM hard drive that stored 10 megabytes cost $1 million and cost $30,000 a month to run, weighed 1 ton, and was the size of a small room. So when you went to your boss and said 10 megabytes is not enough, we want to keep the new address and the old address of each client, we need 2 of these hard drives. They tell you to take a walk and print out the backups and have those as reference, but the online system is just going to have the current address. Those are the kinds of ultimatums that we had in the initial sort of years of digitization of information systems. So any questions about the background and history as to from our perspective these days? All right, then I'll run through my presentation about moving to that way of thinking and how it can help you.
All right.
How many consultants are here? Anyone as a freelancer, consultant, someone working on contract, non-employees? Who's a non-employee? We have 2 or 3. This will help you quite a bit because it's a way to get onto common ground, get specifications done incredibly quickly, and continue to get real work done instead of going back and forth, especially at the beginning of projects, and also how to look good at the end of a project, not try to fit in the last few things that aren't working. So I'm going to try and see. Let me know if you can see my screen. I'm just going to share. Okay, can we see that?
Yes, we can.
Can you still see me?
Yes.
In the corner? Okay, good. All right, so yeah, if you want to get in contact with me, I'm Dymitruk on all my accounts, Twitters, even Instagram. LinkedIn is obviously just my name. But yeah, so I started this company because I was sick and tired of dealing with uphill battles and wanted to have a place where people could develop without having to do all the management battles and just concentrate on developing things the way they wanted to. And that meant that we're going to do domain-driven design, CKRS, and event sourcing as the only way to move forward for anything we do. The premise here is that we can do, shoot, I just changed the color of my of my letters here. I was playing around with something, and can everyone read the blue writing, or is it hard to read?
I think we can.
Okay, those used to be white. I just changed something, unfortunately, in my presentation, but we'll try and get through it. I'm redoing this presentation anyway with a nicer deck. So this is the last time I think I'm going to run this one. So basically, the premise of event modeling is that any information system can be dissected by looking at 4 key moving pieces, commands, well, primarily events, that's the primary thing. Then commands and read models to do the input and output, but then also have the UI piece to give the actual visual. And that's one of the larger sort of additions that's a primary concern here that differentiates it from something like event storming, which Alberto does. So you'll see there's a few similarities, but a lot of this stuff was already being done on whiteboards in 2008 with Greg Young when he was doing sagas and long-running processes at Wolverton Securities in Vancouver. So there's a lot of crossover because this community all over the globe has been doing their own things and borrowing from one another. On the West Coast where Greg was working, we didn't really notice that just how much of a different direction things went in North America compared to Europe. So you'll see some of these differences throughout this presentation. So the premise is you can describe any information system like this. Basically have a workflow going from left to right, no forking of any kind. It's the story. It's like behavior-driven design, specification by example, but for the overall workflow. So going from left to right, you can cut time into thin slices where only one thing happens. There is no idea of simultaneous. It literally is like reading a book. In a novel, you may have 2 things happening at the same time, but no sentence really talks about 2 things, or rarely does it. It's usually following one train of thought somewhere. So the idea behind this is, again, going back to how our minds work. We want to present things in story-like manner. We don't want this to be a mind map or some other graph, simply because our minds do not work as well to recall maps and more complex structures. Our minds are built to remember stories. And that's why it's a big difference between event modeling and event storming, for example. Event storming is more of an exercise of the problem space, discovering it. Event modeling is more about being able to quickly articulate a solution and maybe iterate multiple solutions quickly to explore how you might solve a problem space. So it's a different angle to the whole thing, but tying into very strong patterns in our brains to make sure that we're using things that is natural to a human being. The other thing that you'll see is that there's very few moving pieces here. There's only 4 patterns that we use to specify any of the interactions, as we see later. The key point here is I want to use just my native language, which is English, or Polish if I'm in Poland, and I want to use 3 or 4 moving pieces. And I want to be able to explain this to someone in 15 minutes to half an hour and not have them have to, read the blue book, right? You end up losing an audience. The more you make an audience learn, the more of them you lose, and you won't even know. Some people will tell you that they've read the book, but they didn't. Some people will have read the book and they tell you they understand, but they don't. Some people don't understand, but they lie to you that they understand, right? So you see that the more you ask of your audience, especially in a business setting where it's risky to say, I don't understand, the less likely you're going to have a good communication mechanism. So you have to always find the essence, the truth of it. Like Einstein found at the end of all of that relativity research, a simple formula, E equals mc squared. That was a lot of research to do that. But now that realization that E equals mc squared carries so much more in terms of communication about physics, just knowing that. So we're trying to do the same thing. We're trying to distill the true essence of information systems so that we have very honest building blocks for how these things are built together. And then if we can marry that with how we communicate, then we have a solution, technology, UX, UI, all being able to play on the same playground and be able to communicate. So a lot of the mechanics of coming up with this will go through, but they're very similar. So I really wanted this presentation to just be one slide and then just look at different views into this particular diagram, right? If you want to innovate, you can just start with wireframes and events. The events, your bounded contexts from the DDD world, they're simply swim lanes. I don't want to have to educate a business person about bounded contexts. I just want to say, yeah, that's an event. We're going to organize all the payment stuff in this row, right? So if this is a hotel system, the top row might be your room reservation system, the middle one might be your cleaning, and the bottom one might be payment, right? But you have all those events living in separate swim lanes. And I can explain that to someone that's in QA. I can explain that to someone that's a customer service rep. I can explain that to someone in business. I don't have to have them read a specific book to understand it. Likewise, in the top, we can show two different users. We can show the administrator or the clerk behind the desk at the hotel, and the actual person that's booking the hotel room online. That's a separate row. So those two separate rows at the top are the screens over time that each person sees. And it's very much like a storyboard. You can see how this looks like a movie storyboard from Hollywood, right? And this is that specification by example at work, but being able to tell an entire story about what's going on. So from a security perspective, sorry, go ahead.
Sorry. So is the diagram organized in swim lanes, for example?
Yes. Yeah. So from left to right, you can see the orange boxes are in separate. Those are events, and they're sitting in separate swim lanes to demonstrate that we have three systems. And of course, we know how to do microservices properly, right? And that they're going to have their own storage of their own truth, right? They're going to be autonomous. So that's easy to tell to a business person by just putting them in different streams. I don't have to go and explain domain-driven design. I don't have to go and explain a microservices book to a business person. This, again, should all be common sense. This is just information systems. So all the DevOps and all those other things, they can be put into a side project called infrastructure. But when you're delivering value with features that are working, you're using things that have incredibly little obstacles, like no obstacles between how the implementation is done and what the business talks like. And this is, again, a common sense way to say ubiquitous language as well. Here you can start to see that, why are we using this word in this swim lane and this swim lane? I don't have to reread that ubiquitous language chapter from the Blue Book with the business person, right? I don't have to indoctrinate an entire organization into reading a book to be able to communicate that I want to do DDD. I shouldn't have to say those words to do DDD, right? So this is kind of a way to give you those tools to be able to get the same goals that you want out of domain-driven design without forcing people to say, hey, accept domain-driven design as a good way to do things. Use these terms like aggregates and all that. You're going to lose audience. There's people that the more you ask of them, the fewer are going to come along. And that's where you lose. So you got to make sure you have patterns that you're using that are simple, quick to explain, don't require extra learning. And then you can test their understanding almost immediately by having them do real work instead of saying, I understand, and nod their heads when they don't, right? So same thing with security. When a security audit comes in and we have a solution that's has a blueprint like this, they can see on a timeline exactly where a piece of information crossed the boundary. They can see when they stored that key, when the key rotation happened. They can see it on a timeline. They can see which serve APIs that provide those endpoints. So, for example, for my company, we have a security partnership with a guy that did security at HSBC, really good friend of mine. He says that his work gets cut down to a fifth the time when he's working with a company that has an event model for, as a reference, as a blueprint for their solution, because he knows exactly where to go. Before that, what he had to do was he had to interview all the tech leads. He had to hunt through source code. It took him an entire week just to get going, just to find the places where to look, right? And they threw all sorts of diagrams at him, right? The whole UML thing. I went to one company, they had, I think, 100 diagrams. Are you kidding me? Who's going to keep those in sync? So you need this kind of blueprint where everything can be in one place and nothing falls out of sync. The more places you have because you want to organize things, that's fine, but there's a greater chance things are going to fall out of sync and people are going to forget about that other document. So you want to keep it in one place. Another reason this is called a blueprint, right? Event model is like building a house and having on that table that one blueprint, so the carpenter and plumber, they all know what to do. They know that this, you know, the carpenter knows the holes have to be drilled to this diameter because the pipes are that diameter, right? We don't have that discipline in software. It's all agile, throw it against the wall, see what works, reactive, etc. Well, this is a way to kind of do what Waterfall was trying to do. Although Waterfall has, you know, I just had a conversation with Mel Conway. I met him in Boston, and he said, you know, the basic premise of Waterfall was legal. It wasn't really about how to build stuff. It was the legal precedent that the team that was doing the specification could not be the same team that did the implementation. It was a legal reason. It wasn't because this is a good way to build software, right? So there's a lot of interesting, when you start to look at the reasons that we're doing certain things and why Waterfall ended up being such a mess, it's because of things that we don't think about. We think it was just some armchair architects that wanted to feel important and a lot of red tape. Well, the red tape actually ran all the way through to the legal department. So yeah, those kinds of projects were, you know, digitalization was only available to the companies that could afford it. So all those software practices were, you know, the guys that could spend $1 million on an IBM hard drive. And so you had a lot of legal stuff going in there because of the sums of money involved. So anyway, I'm kind of going off on off the rails here about explaining some of these side things. And needless to say, security, you can actually look and see exactly where things are. So for security audits, it makes it a lot easier to do that. It also makes it a lot easier to separate payment subsystems. Notice I'm using not domains, I'm using words like subsystems and systems, something that someone else could understand. Yeah, you can look at those and see exactly how they're isolated. When there's an audit, you can hand the auditor the blueprint and show them exactly where things live. Okay, so the two big things that happen in information systems, whether they're digital or not, is that, and this is kind of how CQRS is in every information system, even though CQRS kind of came out of these like online super performant trading systems, it distilled the true the nature of an information system. And what we notice is that a better way of saying that each system, and this is from systems thinking and all that, there's inputs and outputs and controlled borders and all this. So how do you say input and output? I don't like input and output because it kind of infers that in order to have output, you have to poke the system in output. This is why you have these people that when you go to business for the first time to do these kind of workshops, they'll say, well, I want a command that says, you know, get user list. That's not a command, right? Everyone knows that in this room probably. That is a view. Like you poked the system before to put those users in, but to get the current list, you're just looking at outputs that were put out before. They didn't come in just because you queried. Anyway, so the way I say input, output, or CQRS, or any of these other systemic thinking things to business people is, as I say, an information system has two purposes, each information system. One, you want to empower the user, which means when the user interacts with the hotel booking system, they're going to be able to rely that they affected the system, and that when they go on their vacation, they're going to be able to stay at a hotel. They affected that system. Their registration is somewhere, maybe even on a piece of paper. They don't care where, but when they show up in 2 months, they have a place to stay, right? So empowerment is one. of the ways that you look at a system. And the other one is inform, right? When you're booking your hotel, you're looking at a calendar of available dates if there's rooms available. So this is the input output, but put in a better way. And of course, we have a traditional given when then specification at the bottom, how we validate how information goes in. The blue part that we glue to the UI. Now this is another thing. You'll notice that this glues every single event, every single property that you have in a field all the way down to where it belongs in an event. And likewise, for a read model, where it comes out on a screen. You can follow every piece of information all the way through the system in itself, do a completeness audit. And that's quite important. And this is why the happy path is so important when you're doing these elaborations with businesses to show them how the system's going to work, is that you can trace through exactly where each value came in. If you can't tie it to where it came from, or you can't tie it to where it's going to go, well, then why are you asking for that input? It's got to be justified, and you have to have that discussion with business in the room and everyone else in the rooms to keep everything honest and not have silo type of, you know, ivory tower dreams from different departments about how things should be. And notice how important the UI and the UX is at every step. This is the honest way to involve people that are doing all of the critical questions to the customers about what they feel is a good interface and what is a good user experience. When do they expect to see that email notification? When do they expect to see a mobile notification? When do they expect to be using the full site versus the app? Right? Those questions can only be answered on a timeline. And so for UX UI people, this is critical. When you're looking at this behavioral sort of behavior-driven specification by example for the entire workflow, it's quite important for UX UI concerns to be there, so that people understand why things are in certain places, and that the people that have been doing the cognitive load analysis, et cetera, they have a way to, you know, explain it like M5 to the rest of the group to say that this is why we're having these things in this order, right? Does that make sense to everyone?
I think so.
Yeah, I've been talking a little bit fast and all over the place, so if there's any questions, this would be a good time. No questions? Okay, we'll keep going. Let's plow through this and leave everything till the end. So we got, sorry, there is a question I heard.
Can I ask what is how the UI screen on the top in Power is the intention of the user, yeah? That's in Power.
Okay, can you repeat that?
In Power section is the intention of the user, yeah?
Yes, absolutely. And you can see exactly where that intention, this is another important point, because this is where you have that task-based UI way of specifying everything that's going to happen. It's not forms over data by default. By default, it's a command-based UI, so that you can see that when I want to, for example, register or book that particular room, it's an atomic operation, either succeeded or didn't. It wasn't a partially filled form or whatever, and it wasn't passively just stored in a table. It was a command that could either be rejected or accepted, and that's why our given when then below is easy to set up for business to understand. We have given that this situation occurred, person signed up, person put their credit card in. When they tried to register for a room, then it failed because there's no inventory. Or set up the same thing, but add the room to the inventory. Then when they try to book that room, then it succeeds. And the only way you mark success is by storing an event called room booked. And that's it. That's the most responsible thing to do at that point. And that's what regular businesses do before digitization, is that when you come in, something happens, the clerk doesn't have a chance to check all inventory, et cetera. They just say, based on my knowledge, you are allowed to do this. Here's a receipt, here's my copy, and I'm keeping it. We'll do consolidation later. So businesses always worked with eventual consistency, and they always worked with just marking things down as, yes, this happened. And that's why there was a time and a date on receipts and other forms, and you just file it, and there was always a reconciliation. So the entire business world and humanity itself is very at home with the way event source systems work. Now, that doesn't mean you have to implement this way, right? It says, oh, event source everything. Yes, I would love to, but there's cases where that doesn't make sense, and you need to throw away the ledger very fast, but for development, it still makes sense to keep it around. And so you might have a very read model heavy way of working, but it still makes sense to have validation in one spot and all these other good, all these other good practices that you get out of that. But you certainly learn how to, take the right shortcuts while keeping information pure and accurate.
Why do you call it validation?
Because it's the thing that allows the event to exist. It validates the event. That's why commands and events are almost one-to-one, right? They're almost always, I want to register and here's the information I'm registering with. And it's like, okay, cool, that's awesome. That email doesn't exist and blah, blah, blah. Whatever your other validation rules are, if they all pass, what do you store? Well, you store what they sent you with the command, right?
Yeah.
It's pretty simple. A business person can understand that, right? I don't have to go into the details and dig a hole for myself to explain things over a week. I can say that, hey, this scenario I'm setting up here where, the admin adds a room to the inventory and then someone registers and then you put in a credit card. When they try to book that room, I can say that, yeah, that's enough prerequisites for them to be allowed to do that from a business perspective, right? And the catch here is that even though that's articulated from a business perspective, it translates directly to code. That's what we want, right? That's our holy grail in being able to help customers, is to make sure that that translation is as tiny as possible. So same thing with Empower. The only difference is that we don't have an action. So we don't have given when then or act arrange assert. We have just given that these events have happened then, and you have what your calendar looks like, for example. Those setup events could be this room was booked for this time, this room was booked for that time, et cetera, et cetera. Therefore, after all that's done, my calendar will look like this, right? A business person understands that, right? It's not a technical thing, but you can see how this directly translates to code, right?
Okay,
again,
it's a little bit easier, to be honest. But I cannot visualize how you can store a command as an event. You store
you create a new event. You don't store the command. I mean, you can if you want. A lot of people do. There's some frameworks that allow you to just tie the command to the event that's stored. That's fine. But for the most part, people don't.
Command produces, yeah.
No, the event would be if the command says what's it called? Book room.
Book room.
If it's book room, then the event that gets stored is room booked, past tense.
Okay.
Same fields, different objects. Just serialize it to JSON, write it to a file. I don't care. Everything else is secondary. The fact that this happened, it has to be recorded and timestamped, etc., whatever you have. But it's got to be there, and that is the first thing you do, is you got to store that. That goes onto Ledger. This is where things fall apart with Kafka and other things like that, is that they tend to use this distribution system as a storage system, and they don't realize that a lot of times the storage comes after the publish, and what happens when you flip the switch? How do those other services now go back online when they can't get the event? Some of them can, some of them can't in the distributed one. Now you got inconsistencies that are hard to come out of. So you always get that ledger solidified before you do anything on the publish side. In other words, this always has to come before this in terms of an event, not like with the Kafka approaches where you publish before you persist. It's a ridiculous preposition. So these are the first two things, right? These are the two formal patterns, input and output. And you should be able to talk to anyone about it. The other two variations of that is how systems talk to one another from left to right. So let's say I have a ride-sharing service and I need to find out where the cars are that are closest to me so I can book them. Well, these kind of specifications to talk about where the other car is would be really horrible if we had to use latitude, longitude, right? But guess what? From those cars, that other external system, those events are longitude and latitude. And so inputting information from external systems, even our own internal integrations end up being this way. This is your anti-corruption layer, given in layman's terms, that you don't have to have anyone read Eric's book. You can explain it to them this way. That an anti-corruption layer is like updates of longitude and latitude for a car driving around that then gets translated to something that we want to use when we speak in business terms, such as I am downtown, I am at the airport, right? That's what we want to use as the terminology when we're specifying what to do when we pick up a passenger or not, right? Does that make sense? This is your ACL without having anyone read the domain-driven design book. Okay, that's input, that's information that's being put in. What about information going out? We want to send a notification that your driver has arrived at your door. These are all abstracted by something that business can understand as well. That's a to-do list. You don't have a queue, you don't have any of these other things. You don't need any information. We've been doing these types of things for thousands of years in non-digitized information systems. So let's use that same terminology. How do we abstract having notifications for people that are in that specific area for that ride-sharing service at the airport? Well, we make a to-do list. Hey, someone notify these 5 people that these cars have arrived. Okay, so what do we do for those line items in that read model? Notice that the specification at the bottom has that green box at the top. That's the to-do list. That's basically saying, hey, I have this person's ride that's ready, and I have this person's ride that's ready. I need to notify these 2 people. So now some automated process, and I don't care who it is or what it is, it could be Mechanical Turk even, it doesn't matter. They're going to send a command to an external system to say, send notification on their platform, which might be iOS or Android or who cares, or it could be email, doesn't matter. And if there's an error, it'll come back as an error event that you put back into your own stream that's called couldn't deliver or delivered successfully. And guess what? That read model also subscribes to those. And that's how it puts checkboxes on the to-do list so that the automated process or manual process doesn't kick off the same notification again. But again, I can explain this to a business person. I can explain that to a customer service rep. I can explain it to anyone without having them to read any books. I can say, this is how we integrate with the external notification system. I can even show them all the fields on those properties. I can say that it's going to this email and it's going to contain this message and it's going to get sent at this time, right? I can elaborate everything that I need in any of these pieces without having anyone have any technical knowledge or otherwise formal training in any practice. Does that make sense? These 2 are important because they're just variations of these first 2, but we don't get a UI for cross-system stuff. So we need to look at how these things are done from the perspective of just systems that are automated. But they're essentially, again, ingestion and output, right? Ingestion, output. That's all we're doing, same thing. 4 common patterns that you can talk about anything, right? And this, I always draw a funny robot or something. People drew, you know, R2-D2 and stuff in the workshops. They have fun with it, right? They can give it a character that, hey, this guy's always, he's the mailman. This is the robotic mailman. He's sending out, you know, the email notifications. And they have fun with it, and they understand just by a visual cue on the storyline that this is where they're going to get maybe a little spinning circle because they're waiting for an external thing to happen, right? And from the UX, UI perspective, they still see what's going on. Now here's the awesome stuff. When you divide up your work into something that's time-based, you get an incredible amount of parallelism. Because what we've done, essentially, is created very strong contracts at the edge of every workflow step, which means we have a very strong open-close principle from the perspective of workflows. That is incredible, to be able to say that my refactoring efforts for doing workflow step 5, or whatever this is, 4, does not interfere with the refactoring work or the development work of step number 6. TDD has always never really had that boundary. It's like, what is the scope of TDD? Sure, the good developers might have a good scope for it, but the juniors don't, right? So we can't make it something that just, well, we'll do our best. Let's have something that actually draws lines in the sand where your work begins and where your work ends, right? To the left of each workflow, I have a very clear specification as to what the shape of the data is that I expect the system to have in it. And at the end, on the edge of my piece of workflow, I have a very clear contract with what I am leaving on that ledger for the next steps. There is no mincing words. And so we'll get into more discussions about this. How do you do change management? How are you agile with this, right? And it comes down to being able to have business justify what they're changing in a very quick way. This is not about, you know, changing a 50-page document in the waterfall process. No, this is literally, you know, the real-time board goes up and we're off to the races almost immediately, right? So that's where they can do that. They can copy the whole thing, paste it again, do the changes, hold it up against the light, see which workflows they changed that have already been implemented, which they've changed that haven't. They can follow the data to see what other workflows are affected and what they have to change, because now you have an open close principle on that, and that gives you a finite amount of work for each thing. That, very importantly, and this is the killer for, this is where no one can argue with this approach, is that you can say that a feature will cost the same whether you implement it as one of the first 2 or 3. It'll cost the same amount if it's the 100th feature. That is not something you can do with Agile. And I've tried for decades. And different teams have different mixes of people, and all the estimates, they change. The minute you move something in a typical Agile project in terms of the Kanban, your backlog, you move things up and down in your backlog, you've just thrown away the estimates that people did, their t-shirt sizing and all that. They're in the garbage. Because the order of implementation in a traditional way of doing things with Agile, the refactoring process, tightly couples the work. Does that make sense? It's a lot to take in right there.
Adam, I was wondering, how do you test the feature before you roll it into production? I mean, with your approach, how can you do like A/B tests or things like that without breaking the system that's already in production?
We copy the production data, the events, and replay them locally all the time. It's one of the, well, that's why we choose event sourcing, is because it's so easy to replicate anything in any environment. I mean, we had a cloud-based solution, for example, and one client at the last minute says, we want it on-prem, right? We've been building this in the cloud, and I said, no, we want it on-prem. Well, guess what? We did it in 2 days. We just were able to move the events and redo all the read models, and it was no problem. So a lot of this kind of stuff ends up being quite easy. We have an infrastructure folder that just keeps growing, but every single thing that we ever build is cookie cutter to these types of things. So all the different command handlers and read models and projections, they just get different logic for different things. And empirically, we can say that we will build any particular workflow step for, I don't know, $1,500. And then I can subcontract someone and pay them 1,000. But they guarantee that it's going to work forever, because I know that they're not going to get tripped up by other requirements coming in or other people's work. So they should be able to guarantee that it's bug-free. So that's the kind of thing we also give to clients. And that's why we can have a constant curve, and we can say that we will do fixed bid projects. We're not afraid at all. And we'll end on a high note because there's no risk of overspending. Every single step costs the same amount of money, and you get that velocity number by doing projects, right? We're into, you know, tens of these types of projects, at least large projects, and so you know, hundreds if not thousands of these workflow steps, and so we have a really good number of what that velocity is, and then we can predict, like, actually do proper estimates, but not in the way that Agile teaches estimates. It's not t-shirt sizing, etc. It's entirely done from an empirical perspective of looking at the history of what it took to build projects, and say that, hey, our seniors can do 2 to 3 of these workflow steps every week. The juniors, they can maybe do 1, right? And someone that's learning to program, they take 2 weeks, but that's okay. Just like an apprentice in a blacksmith shop, that blacksmith doesn't all of a sudden have a worse service because he has an apprentice, right? Whatever work that the apprentice does that's good enough still goes out, and those horseshoes get sold. Same thing here, right? So you have that ability to say, does this workflow step do what it's supposed to? Because it's pretty cut and dry what it's supposed to do. And whether you're a junior that's taking a week to do it, or a senior that's taking a day to do it, it doesn't matter. The end result is the same. It either does this or it doesn't do it, right? So this is gold. This is literally what will save you so many headaches by being able to do that. So what does it look like? This is a system that is an information system for Plenty of Fish, which also has Lavalife and Match.com and Tinder. They have 7 million users concurrently at the same time. So there you can see the wireframes at the top. You can see all the swim lanes start to form. They have read models up there. They still haven't added the actual commands, but they're working on a timeline. They're showing that, you know, that story of success of being able to send messages back and forth and all the fraud detection that they have to have. They're able to do that with business, with dev, with customer. The lady in the front there, that's customer service. Customer service knows how this thing works from day one, and they had a say in it, and they witnessed the decisions, right? It's important to have everyone in the same room at the same time. And this is fast and very effective. And we do it electronically as well with Miro real-time board. This is that ride-sharing thing. You can see I have an owl little 360 camera that records sound and video and pans around to where the conversation is to record them. And again, at the top, we have all the scenarios. Here, the UX UI person, you know, didn't have an outlet for all their work, and all of a sudden they did, and they were incredibly happy because they could finally tell everyone else what their, you know, wireframes meant or their mock-ups meant for everyone, right? Everyone could glue together what they thought the system should do, how the system should scale, how it should be secure, how it should be organized. How can we take advantage of Conway's law to make the teams that we want to represent the architecture that's best for this? It was all done transparently in front of everyone, with everyone there. That entire thing, that was Uber, and we were able to specify and implement the POC in 3 weeks. That's replacing Uber, who took, you know, how many millions of dollars to succeed. But we were able to do a POC that for legal reasons where I live, Uber's not allowed here, but with certain features, an alternate system is allowed. So that's what we did for these guys. So there's a typical project in our, you know, this is a digitized version of what we do. Generally, every time we do this kind of stuff, we do a digitized version that we can share on Miro real-time board. This one cost about this much. So you can start to see how we can average these things out by doing the different workflow steps. Yeah, so I think that's it. Any questions from this? Because I'm going to go into maybe other things I can show you, maybe some resources and other things where you can read up more on this. Oh, that's my book. That's eventually going to get published. I'm working on it.
I think we need the example to actually understand.
Yeah, perhaps we can see some example. How
this is an example.
This, I mean, like actual Postit notes and events and things like that, to have a clearer image of how you design a workflow, for example.
Yeah, I mean, we walk up to a board like the one behind me here, and we start putting sticky notes up, and we say, what happens next? What are the events in the system? So we do seven steps to do that. In fact, I think I'm going to, just give me a second here. I'll put something else up on the screen. It makes sense. Okay, where are we here? Let me share my screen again. Okay, so I put together eventmodeling.org, and I kind of go through this presentation in here in detail. So you'll see I'm reworking it so it looks better, and I've added a lot more. So these are the 7 steps that we do. This is actually from the Event Storming Summit in Italy last year in Bologna. This is where we realized just how different the 2 worlds are. We had thought we were doing what Alberto called event storming, but we weren't. We were literally doing a proper elaboration of process managers and sagas that Greg started in '08. I added the whole UX UI piece to it, and but essentially it builds on what Greg built in '08. So it's quite different, and we look at the history of just all the ideas around domain-driven design, event sourcing, etc., and do that. So yeah, first thing is we brainstorm. We just kind of say, hey, what is your system going to do? And we have an intro maybe for like 15 minutes. What are the goals of the business? Get everyone on the same page. Like, hey, we're building, I don't know, a hotel system, right? And then we have everyone say, use their experience from previous work or whatever. We put down what events are going to be stored in that system, like user booked a room or guest booked a room, guest checked out, guest paid, room was cleaned, that kind of thing. You kind of put them all in there. Second thing is we do, I can zoom in. Can everyone see this now?
Yes.
Okay, good. So yeah, so we brainstorm. I'm glad I can pan around. Then we do the storyline, which we kind of went over. We have to make sure that things make sense over time. And at this time, we kind of identify the most important event. For example, if our hotel system has very clean rooms and we charge a premium because we have third-party people, do bacteria samples and all this kind of stuff, and then have that published publicly, then room cleaning stuff. That event, one of those events, is kind of the most important one. We also identify something that'll keep us afloat. Like, we have to make sure that our payment system works. So maybe the end goal event is also good. Those are really good anchor points to start, because we can, with that strong contract, we can start anywhere, and we can see how just stage data can provide enough to actually run the system without the other workflow steps implemented yet. So next thing we do is we add the screens. We make it into this movie, and that's quite important. We want to make sure that people see what is going on from the user's perspective and not just read sticky notes. Some people are auditory, some people are visual, some people are, you got to answer to everyone's kind of way of ingesting stuff. So it's quite important that once you get the storyline, to actually get wireframes. And we do that with pen and paper, Sharpies, and just white paper from the copier, with tape to tape it up, or with software. It's quite easy with the real-time board, which I can show you as well, of how quick that can be. And that's quite important. And then this is quite important, is we identify where we empower the user very quickly. So we tie all the buttons that do something in the UI to show business that, hey, this is how the information gets in there, right? We have to tie those together very quickly and show that this is how we're making sure we're not getting bad data into the system, and we can see when data is getting into the system on the workflow. So it's not just dreams of what the UI should look like. We make it real, and this actually is really important for the UI UX people, right? They can't just dream up crazy scenarios that are just really hard to implement. It's a two-way street, a negotiation, but now you have a platform for that negotiation. And then obviously we make a projection of all those events and how information gets put up on the screen. For example, that availability calendar or the rooms to clean or whatever as a list for the cleaning staff, right, on a hotel system. You need to have those projections, and things have happened in the system, and we're just going to show them in this form. And we draw the lines to show, what things a particular screen is getting information from. And that's quite important, because at this point, you can do the full information completeness audit. You can say that with my happy path, I can say that I can account for each field and everything displayed on every screen to where it's actually going to get stored if I ever lose power, when, what time am I consistent to, what happened there. And this is very important. This costs, if people can't do this, this can literally cost millions of dollars of headaches and lost businesses, etc. So one of the primary objectives for event modeling is to, at some point, it doesn't have to be immediately, but very soon, you should be able to do a proper audit that I've accounted for all information. There's nothing missing here. And that means that each contract is good, and you can have faith in the fact that if you complete a particular workflow step, you're pretty much done. That done is done question is answered for you. Sorry, did you guys hear this last thing? I got a pop-up.
Yeah.
Okay, you upgraded. Sorry, I made you upgrade. Okay, so does that make sense? And this is, I usually put the legend there. And then we organize, right? This is where the real blueprint comes in from the technical side. You can say that we have admin and customer, and then we have inventory, pricing, and payment, right? We can do those swim lanes. Time still goes from left to right. We have every time, the important thing here is that we can slice this vertically, and the very finest slices are always going to give us one step forward, and it's going to clarify a contract. That's what we want. We want it to be as explicit as possible. We leave nothing to question, right? At the end, like before any work starts. That's how you do the right, like this would suck if it took a year to do and it was spread over 50 documents. I would not want to do that. But this is easy. This is as short as an afternoon, right? And why don't people do that? That's that responsible level of design that we were missing in the industry. So find a way to do this very quickly and get incredible value for what is expected, and give it a platform where everyone can actually be there and participate. And of course, that's your UI UX split. And then we went through the 4 types of specifications, right? The other important thing here, that little formula that you see there, that's basically saying that any of these specifications are pure functions, which means that the business can understand that given the same inputs, they can always expect the same outputs. Business wants to know that you're building a reliable machine, right? And so when you have those given when-thens, they have any kind of dependencies that you might think you'd have in your domain objects, they get bubbled up and get arranged by an application layer. And those, for example, exchange rates or whatever you might have, they get pulled in as values that get added as properties of the commands. When the command is getting validated, we're not doing any external reach. That means whatever we implement, no matter what, like we don't have to have a functional language, but we're getting a functional paradigm. We're getting a guarantee that given that this input, we're always going to get that output. That's why there's a formula. All the, you can't really read it on there because it's a little smudgy, but the new events are equal to the function of the command and all the previous events. And likewise, the state is just a function of all events in the system. Obviously, you optimize that. You don't actually do that. There's filtration and all sorts of other things to make it more easier to program. But from the business perspective, they want to know that they can have a reliable calendar to show availability, and they need to have a reliable way to always ensure that state goes in as described, right? So those are the steps, and you can find this. So this is on eventmodeling.org. You can find this article there with with these steps actually explained here. So I try to make it as clear as possible, and I welcome your feedback if I'm not saying things correctly, or if you guys want to translate to Greek, I would love it. I can add that happily, which would be kind of cool. But yeah, I give it some, again, business-centric naming, so people don't have to look up any specific terms. Identify inputs, identify outputs. Business people understand this, right? And we can introduce this very quickly to them without having them to, read specific literature. Applying Conway's law, this is how we organize our teams. That's why we have separate systems, whatever you need to do. And then elaborate the scenarios, basically those specifications that we talked about, those 4 forms, right? So, I go through the presentation and a little bit more. I add a few other things. The quite important thing here is legacy systems, because a lot of people have legacy systems. So this is the responsible way of extending something. A legacy system can either be rewritten or fixed mid-flight, refactoring all the time, kind of a moving target, because people are putting in hot fixes while you're trying to refactor. Is a nightmare. There is a third option. If you can actually freeze the legacy code and quickly fix things and add functionality on the side, then you've spared everyone from going into the ugly code, right? And this is how you tell business about how to do that with the same methodology, right? Here, let's say we have Sugar CRM, the open source version, which is horrible because it's been abandoned for 1.5 years, and it's just a kludge of crappy fixes and just zero engineering or responsibility going into it. So you don't want people to add to that mess, right? So you can say, I'm going to take this version, no matter what bugs are in it, I don't care, and I'm going to extend it. I'm going to add the ability to add the profile picture, right? Assume that the CRM doesn't have a profile picture, whatever. We're going to add that. And we also have a bug in the registration system. So we can see that what we do with the legacy system here is we listen to what happens in the database underneath when we do a register through their UI. We install it, we do whatever, and then we do a snapshot of the database and we do a difference. We can see, now we can listen to certain tables, so maybe put triggers, and we can emit these events of CRUD. Whenever we hit that register button on that old CRM, this is what happens. We do that translation layer, which we already talked about earlier, and we put that into our nice sidecar, the clean system, where we have a nice user registered event, right? But we also know that this is something that we have to fix a bug in. So there's another read model that we have in our new system called users to fix, right? And this automated process, remember the robots from one of our specifications? It sends, whenever it reads that, maybe every 5 minutes or whatever, maybe it's instantaneous. I don't care about the implementation, but business has to know that this works this way. We adjust the user to fix that. In fact, we translated backwards the old system, but we don't do it through their code. We do it directly to adjust the data to be correct. We do not touch the old code, right? That's the frozen aspect. Then we raise an event that's called, and store an event called user adjusted. And that actually is subscribed by the same read model, which is that ToDo list, that users to fix. Now that has a checkbox that user is fixed, right? Okay. And here's something that's new functionality, right? It's entirely sitting in the new system, right? Here you can have Nginx or whatever, coerce 2 sets of screens. That's why we have two swim lanes there, right? Does everyone understand this? How you can articulate legacy code migrations to business to give them a price? Because guess what? You can slice this up vertically as well, and you can use your velocities from any project to give them a price and timeline and assurance of quality for this migration. Does that make sense?
It's not always that easy, though, is it?
Yeah, it is actually. It actually is easy. Believe it or not, we're so caught up in our current tooling that the hardest thing to do is to abstract something to have one model to represent everything you want to do in a system, and also do it without any audit trail. So OO and everything has set up a very like object-oriented programming in the monolith with no audit trail is one of the hardest things to get right. That abstraction, if you get it right, is temporal. It won't be right tomorrow because business has changed. It is one of the hardest things to do. This is easy. People don't understand how easy this is because they're so used to that. It's like everyone has Stockholm syndrome and baby duck syndrome and all of the other stereotypes that you hear about trying to change to work in a better way. This is incredibly easy.
Yeah, it's easy to do event sourcing as well.
Do you know what's hard?
You know,
It's convincing people to try it.
yeah, that's hard.
That's the hard. The majority of the tough parts about software are people problems and nothing to do with software.
How do you actually translate root operations to event sourcing?
Sorry, I didn't catch the first part. How do I translate the CRUD stuff to events?
To event sourcing, yeah.
Because that's
Well, it's quite easy. So it's a system that's okay. So I install, for example, Sugar CRM, and I do nothing in it. I might look at the database, see if it's doing some crazy stuff on its own every 5 minutes or whatever, right? Maybe there's some craziness that's going on. But let's just, for the sake of the argument, let's just say if I don't touch that system, the database is the same. Okay, it doesn't change. So what I do to the legacy system is I actually take a backup of the database, then I register a user, and then I take a backup of the database again, and I compare them. And a sane person would have a user table with 1 row added, right? But this legacy thing has 5 tables that it does, changes some statuses on something, updates some counts. I don't really care. Like the code is a mess, and I'm empirically looking at what the hell this thing did. And those CRUD events are such things as, here's a new row for this table, here's a count that got adjusted for a number of users, here's whatever, right? We have a whole bunch of crap that's in there. And let's say the bug is in the count. Maybe it adds 2 for one user instead of 1, whatever. We can see what happens, right? And so this is where the bug fix could be done from that. But our user registered just cares about what we put in the UI. We can see that we can throw away a lot of the changes if we don't care about them. That's the idea of the mapping. It's very similar to an anti-corruption layer, but it's done in a very specific, with a very specific purpose for dealing with legacy code. Does that make sense?
Yeah. I was wondering, okay, suppose you want to build a product that needs to be customized per market segment or whatever. How would you accommodate for this?
You show different events. If it's your business to have 2 different types of events, it all comes down to what you store. Now, sometimes it's the lack of an extra event. One of the things that I like to teach is for people to force themselves, especially if you're coming at it from a technical background, the idea of a null value, right? A lot of times I say, well, sometimes that property can be null on that event. Why don't we remove that property and make another event that either happens or doesn't happen? Do you see that pattern?
Yep.
To get rid of null, you can remove the property and add an extra event that can happen or not happen. Now, you've pushed it off into the representation of the data, the read models. There, maybe you do use a null.
Won't this affect the other systems that are, the other parts, the other components that are dependent on this event?
Well, when you make that change, you have to tell the other system. So this is where, versioning events, there's a whole book on versioning events of how you publish, if you need to publish a directory of your events or a shared DLL. But generally for most people, they're not working with a team that's spread across a lot of places, and you don't need to publish that. For external teams, you do. And that's where you have an API that does the translations for you. You have a typical ACL that you would do, but you keep business isolated from that. You want to keep this conversation as close to implementation as possible for business without getting into the technical talk. And this is the way you do it. It's very hard to get ourselves as technologists to get out of that thinking. But when you do, when you force yourself to not use a special term and use plain, your native language and common sense, that's when you knock down all those barriers, all those artificial walls between different organizations. So A/B testing can be done. Again, you can elaborate about users that fall into, pretend this is not legacy and sidecar UI. This could be A/B testing, right? You could have a decision put over time that, hey, this person came in at their name starts with A, and everyone that has a name that starts with A is going to get this new feature. You can show that on a timeline. There's no problem here. You can show how their data relates back to the other people that don't have that feature. It's just common sense. Literally, what Greg Young always says is like, well, what would you do if this was pen and paper? What happens in a diner? What happens, if we wanted to use old paper copies with carbon paper in between? That's kind of the mentality we have to put ourselves in so that we don't get, blocked on anything specific we learned in the last 50 years. Remember, you got to go back and say that information systems have been around for thousands of years, and these were not problems before. Now, Moore's law is not giving us that small little rectangle to play in anymore. So those constraints as have, we must have third nominal form. We must have this, that, and the other. We can't store all the events. Those are not arguments anymore.
Right.
So did anyone get anything from this that they could put to use and help their organization?
I think we need to run some workshops so that we can get acquainted with it.
Yeah, absolutely. They're way more fun than actually just reading about it.
Yeah, perhaps we'll arrange for the next meetup to have some hands-on workshop.
Yeah, I would be happy to remote in, because we use a real-time board for doing it remotely. So I know there's always people that have to work remote. So it's nice to do that exercise as well. And just to show you, because this thing I put together in like 5 minutes. Like depending on the tool you choose for the online stuff, it's actually faster than sticky notes on the whiteboard. It's way faster to copy things and elaborate. So, you know, I use a mix of the two, and I certainly, even after I do a manual one that's on pen and paper and a whiteboard, I digitize it for a client as fast as possible so that they can look and see what's going on and follow it through, right? I want to be able to get on the phone with them, have them pull that up and walk them through if there's a problem with the design, or maybe there's a better thing, maybe we can talk about scope and leaving some things out. We can have those discussions very quickly without having to be there in person. Yes, in person is the best, but let's face it, the reality is we're moving more and more to be, you know, remote workers and people that want more freedom to where they are. So if you can do it in person, great. Just you can't artificially make that, you know, make that a stipulation on everyone.
All right, I think we'll probably try it in one of the next meetups. So,
yeah.
Any questions? When do you think your book is coming out?
It was supposed to be out in December, but I just got so busy with my business that I decided to put this together. And essentially, the book is an elaboration of these sections. So you will have a chapter that gets into great detail for every single one of these sections. So it's about 23 chapters that the book will have, but it'll go into, you know, a bigger detail than this. And if you go to eventmodeling.org, you can at least find some resources that you can point other people to. So if you have your boss that wants to find a better way to communicate and you're having trouble with the typical, you know, people asking for extra features, they bypass the product managers and the product owners or whatever, the typical, you know, problems with software are addressed by this, and you can just show them some of the resources. I have a Slack group. There's a link for the auto join there. There's also a video of this. It's a worse talk than this. I like, you know, this is from February, and I've really added quite a lot more meat to this presentation, but this is an okay one. It's from a Seattle event-driven meetup. You can point people at that. It's a similar presentation to what I gave you guys. We're doing workshops. So there's a London one that's coming up July 9th. I do have a real-time board template that just kind of gives you this as a way to, you know, start with this kind of thinking and just play around with it. So you can download it and use it. This is a Trello board replacement that's done in this style. And then if you actually want to do the demo of it, you know, with the implementation here, there's a little gist that's here. I love fish shell, so you're not going to be able to use bash, but it really has no real requirements. It's kind of like, how do you get going into implementation very quickly? Because one of the things about event modeling, and when you're ready to go, like we can do we finish an event modeling session, and the next day we have a working slice of the most important thing. And clients are like, how the hell did you do this? And how do you know that it's going to work when we're scaled out to 7 million users? But it's like, we know because we have functional paradigms at play. We have really well-defined contracts. And unless you change the requirements, it's going to work at scale as it does right now just in the browser. That code is not going to change. You want to give them that. So yeah, those are the kinds of things you want to do. And the reason I put this here is because I wanted people to know that it's not a complicated thing. You can do it in a script. You don't need to have some event store deployed. You can have it in memory. All that stuff is infrastructure, and you should really be concentrating on your on the projections and concentrating on your validation rules that are going to live on with the information alongside it through the evolution of the system. That's the important stuff that's going to live on, whether you're deployed on a small cluster locally, or your dev machine, or some other cloud provider. That's going to change. So you want to have the stuff that's deployed to wherever it is to be solid. And that's kind of why I put this thing here, to show you that you can get going immediately, even if it's a shell script. Those state transitions are codified and reliable and show the contract's working. And even if it's just on the command line, you can show that I do have a Trello board working, right? So that's just for you to play with. And you can notice that you don't have to have the typical event sourcing and CKRS and DDD paradigms in there to do the same thing, and to just be able to code right away and not have this, where do I start, a giant iteration 0 and CI/CD setups. Like, no, you should have no obstacles to start developing once you have an agreement with business, and show them real working code a day after you've had this session with them. Say, hey, this thing looks pretty crappy. Let's try it again. You want that most important thing developed right away. And this is the fastest way to do that.
All right. So thank you very much, Adam. We're very, very happy that you did this presentation for us. We'll bug you on Slack or Twitter or whatever for more. I'm sure everyone will be following up on this. So
great. I will be, one more thing, I don't have it here, but I did plan, I'm going to be in Poland on the 12th and 13th as well. So if anyone's in that area from your group, there's also an opportunity to meet up. I think the 9th in London, there's also a meetup that evening that I'll be at. So yeah, I rarely get to go to Europe because it's such a far trip from Vancouver. But when I'm there, I try to make the most of it. So hopefully some of you I'll see there.
There are some Meetup members in London, so maybe we'll let them know and they can arrange something.
They already announced it. Yeah, DDD London announced it already.
All right.
Yeah, I'm presenting with a CTO of Event Store, Chris Condren, there. So it should be fun.
All right. So thank you very much. Have a good day.
All right. Thanks, guys.
And we'll be in touch. Thank you.
All right. Bye-bye.
Bye. Bye.